Hello. I've had guests yesterday and played tennis today. Yesterday I prepared starting on problem 2b, but today I think we should do it. So I wrote up the series expansion for f and theta to the fourth. Now this is wrong. It's only with odd ends, so here n is naught, so we need to remove that. And then let's see whether I'm home here. That's theta and theta to the fourth. So we use the binomial formula first for these two. That gives 8q and q squared. That's 4q squared, and then 4 times 4 over 2, which is 6. Ah, my God. So that should be 24. And the next one is 4 times 8. That's right. And then q to the fourth. Then we have 4 times this. That's 8q to the fourth. And then this to the fourth. That's 16 plus 8, that's 24. Okay, so let's believe that. This is not normalized, of course. That means that we have 1/8 here, and then the coefficient to q is unity. But the idea was to use this formula to compute the Tn, T2 of f and T2 of theta to the fourth. And that means that n equals 2. The greatest denominator of n and 2, d divides that. And so if it's odd, it's unity. There is only one term. All right, now let's see. M, that was 2. And then this is wrong. I must have miswritten that. It's m, isn't it? M times n. That was an absurd number of mistakes there. A 2n divided by d squared. All right. So T2 of f of z, n is naught. I actually never really checked what to do when n was naught. So I think there's no one there, because it's a cusp form, or rather it gives naught at infinity, so there can't be one there. So the first one is where n is unity, and then chi here, that's the trivial one, modulo 4. So chi of d equals 1 if d is equivalent to 1 modulo 4, minus 1 if it's equivalent to 3, and otherwise it gives naught. So when d is 1, then it gives 1. It's a2 divided by 1, all right? So that was the first term. N equals 2, then d is 1 or 2. 2 gives naught, so it's only d equals 1 that counts. And that's a 4, which is naught. Oh yeah, all the even ones are naught. So that's naught. And q to the third, when n is 3, d must be 1. So it's 6. That gives naught as well. That's very weird. Let's just try g2 of theta to the 4th. I'm a little unsure about the constant. When m is 2, then we have only 2 lattices we can use, so that gives 1 as well, I think, plus. And when n is 1, we only have d equals 1. 2 divided by 1, that's a 2, that's 24. And when n is 2, d is 1 again, because chi of 2 vanishes. So n is 2 and d is 1 unity, so that gives a 4. That's 24. Let's take one more. When n is 3, then we only have d equals 1. That's 6, a 6. Oh, I didn't write that. I would like to have it so that I can check. We can only get q to the 6th in one way. That's one of these, 2 of these, and 1 of these. And these 2 can be calculated in 4 ways, and then we have one more. So it's 8 times 4 times 2, that's 8. That should give 64. It feels wrong. All right, let's now go back to T2 of capital F. N equals 2. We have D equals 1 and 2 vanishes, N equals 1. So that's 2, A2 divided by 1, that's naught. So we try n equals to 3. That gives unity as well. 6 divided by 1, that gives naught. So we try n equals to 4. That's 2 here, so it's only 1 and 2, so it's only 1 we use. And that's 2 times, now what was it, 4, that's 8. This is really absurd. I think we get no more, but that's impossible, because this should be linear. We should be able to express this linearly in these guys. And when there's no constant term, then it should be a factor times this. So we should definitely get, I said A2, Oh, that's 3. So when we get 3 here, we should have gotten 9q squared, etc. Let's check. 1 plus 24q. So if we add 16 times f, that's 48. 48 and 20 is 72. That's not what I got. I'm doing this wrong. I think my problem in the beginning of the problems here is that I did understand the material, but it's in small boxes, and I'm not able to jump from one box to the next. I don't know the subject matter very well. And therefore, when I use this formula, I get confused and don't know what it comes from. So while drinking my afternoon coffee, I still have got a cup left though, I went back and made the operator T2, which is very simple, on the modular point. Simply writing it up, and that came out very simple. So I hope this formula will give the same result when I go through it. Now let's check. This was terrible. M2 of gamma 0.4 equals M2 of 4 with the identity or the trivial character of order 4. So it should be +1 over here. +1. There we go. So if it's just and naught when 2 divides d. So m equals 2. When n is even, it's 2. And then chi of 2 gives naught. And if m is odd, the greatest common denominator is unity. So we just have Bn equals a to n. Well, that's as simple as that. And that means that T2 of f vanishes because the even coefficients vanish. They are here, 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 and here, and here, etc. And now the theta function, should we do it on this guy? Yeah, let's do that. So it just gives the even ones. And then the rest we should find using Maple. So there you have it, easy to see. Well, it turned out I had prepared to do 1/8. And here are the series. They continue, of course. And subtracting, we see that the even numbers cancel. So the odd ones, yeah. And here we have f, q, 8q to the... Now what's this? I even made f wrong. It's only the odd ones that occur. And 5, that's 6 q to 5th plus 8 q to 7th. 9, that's 1, 3, and 9, that's 13 q to 9th. Oh, we don't go so far. So you see, they are just twice, and that means we have the general formula. And 2 times 8, that's 16 f. And that means if we are in a basis, oh, here I should have found and base theta 4th and f. So theta 4 maps to, we write it up here, to theta 4 plus 16f, and f maps to naught. So the basis is theta to the 4th point and comma f. Now we should compare with alpha 4, and we did actually find the matrix of that in that problem. I'll just make a break and find it. So I found the result from problem 15c, and it realized that I made a small mistake there. It's 16 and naught. So this is, yeah. And we can just multiply the two matrices in different order, and then that should give something different. So that's like the general way to prove it. G2 alpha 4 and alpha 4 G2. So they don't commute. All right, now we have done C.